Cool. I think we can get started. Meanwhile, other people can join later on. Fine. So today we will be going to start Python level 3, right? So in Python level 3, primarily I will be covering the functions and the exception handling and classes and objects. So the first thing that I'll be covering is functions, right? So what are we going to cover in functions? Let's see that. So first is basically the syntax of any function in Python. Then what is the difference between parameters and arguments? And then type of arguments that you can, pass when you're defining your function. And this will basically, okay, once we will come to this, I'll add this particular node, subnode at that time when I'll explain, right? Then next thing that we will be going to see is global versus local variables, right? And then there are some rules to these global versus local variables. That rules also we will see one by one when we will come to global versus local variables. And then next thing will be uh, nested functions. So if you are from Java background, so there is no concept of nested. There was no concept of nested methods, right? So in functions, we can have nested functions. And then we will also cover some part of lambda functions. We just call it as lambda, right? So let's get started. So first thing what we are going to cover is the syntax, right? And before that, so what is function? So basically, function is a piece of code which only runs when it is called. So it's a piece of code or logic which only runs when it is called. So if it is not called, then that particular piece of code uh, will be there in your program, but it will be only run when you will be calling it. Now let's create a simple function here, right? So let's create a function. So in order to create a Python function, you have to start with a keyword def, right? And then function name you can give, let's say I'm giving f1 and then colon. And whatever function body will be there, it will basically everything will be after the indentation, right? Indentation of 4 spaces. So if I'll write print hello, so this becomes function. And if I'll run this program, nothing is happening, right? Because this piece of code, as I said, right, it will be only run when we will call it. So this particular part is defining the function. And let me call it. So how do I call the function? I'll just write the name of the function and open bracket and close bracket. Now, when I'll run this program, it will print hello. So this particular part is basically, it's a creating a function, and this is calling a function. So this is creation of function, and this is function calling. So this is the basic, very basic of how do we create the functions. Now, as I said, right, so this particular thing, it basically, whatever is there in the function will be, I mean, the function body will be containing or will be there after 4 indentation. So if I'll remove this and if I'll run this program, It will not run. It will say indentation error, right? If I'll run this program, it is printing hello. So if you remember in our first lecture, I have told you, right, that indentation generally is four spaces in Python, but you can have any number of spaces. It's just that you have to maintain that space, right? So let's say if I'm giving one space here, inside function, then rest of the code will also follow with one space only. Print, let's say again I'm printing hello. So it will be basically the same indentation that you need to take care. So one space is also fine. Even let's say instead of one space, if I'll give two spaces, then also it should be fine. It's just that whatever indentation you are defining, it should be constant throughout. But generally, when we press tab key, it by default adds four spaces. So that's where the practice of keeping four spaces as an indentation came into the picture in Python. Cool. So this is about the syntax of function, right? Now, if you look closely, so this function, we are just, opening the bracket here and closing the bracket here. So there is no, uh, you know, okay. So what we are discussing now, parameter versus argument, right? So I'm coming to that. So there, we are not passing anything inside these brackets. So let's say if I'll pass anything inside bracket, let's say name I am passing and hello name I am printing. Yeah. Now what is happening is that I have defined one variable name in the when I'm defining this function. So this particular thing is known as parameter. Cool. And when I'll call this function here, so here what I have to do, I have to pass some value. Let's say okay, I'm passing Vedansh, right? So what is happening now? This Vedansh, the value that I'm passing here, this is an argument. And in the function definition, whatever variable name is mentioned there is known as parameter. So this is a fine line of difference between parameter and argument, and sometimes people interchangeably use these terms. And let's say when I'll run this program, it will print hello Vedansh, right? So this was about uh, the difference between parameter and argument. And here, parameter, this can be of any data type. It can be number, it can be string, it can be list, it can be dictionary, it can be anything. But whenever you define the data type, any data type here, it has to be, basically that data type, we can pass it from here. So right now, uh, if I am, if I see this function, just by, just by the variable name, I cannot define the data type, right? So whenever I'll be calling this method, here if I'll, let's say if I'll pass 1 comma 2, so it will basically accept this particular parameter as a list, and it can be anything. I can pass number also. So it is accepting number here. So this can be of any data type. I mean, the parameter of a function can be of any data type.
So, just one question, Abhinav, that how it's adding a space between hello and the parameter which we are passing here?
See, the thing is that we have seen in the print statement, right? That
Uh-huh.
by default, so print function here, it can accept, zero parameter, zero argument, one argument, and two argument, right? Or
Mm-hmm.
sorry, more than one argument. And each of the arguments that I'm passing, if you see here, I'm passing two arguments, right? And each of the arguments is separated by a space by default. So we have seen the difference between concatenation function and this comma, right? So when I'll do this like this, and if I'll pass some string value, then in this case, there will not be any space, right? But if I'll make this as comma, because here in this case, if you'll look closely, how many parameters are there? How many arguments are there in print statement? Only one argument is here, right? So when we are using this concatenation, then it do not include any space. But when I'll use the comma,
Okay.
it will
Yeah,
by
yeah,
default.
that makes sense.
Yeah,
Yeah. So it's not there in other languages, it's just Python specific.
yeah. So here it will include one space by default between the parameters. How many parameters? I mean, it can be any number of parameters, and it
Mhm.
will separate all these parameters with a space.
Okay. Yeah.
Now, the type of arguments. So, uh, okay, first type of argument is basically the simple argument. Simple argument. Simple argument is something that we have just seen, right? Just a variable name or couple of variable names. Then we can have arbitrary arguments. Then we can have keyword arguments. Then we have something known as arbitrary keyword arguments. And then we have optional arguments. So let's see these one by one. So simple argument we have already seen means if I'll provide just the simple variable name comma name one I can provide, right? And it can be any number, right? Hi. So this is an example of single argument that I am passing. And here in print statement, let me include all these arguments. So hello, hi Python, it is printing. So this is an example of simple arguments. Now let's see how the arbitrary arguments basically work. So when we are sorry, when we are not sure about how many arguments will be passed in the function, then in that case we add a asterisk symbol before parameter name. So what I mean is, if I will include um, asterisk and then let's say tup I'm writing. So in this case, what is happening? Let me first remove this. Here in this, when I'll be calling this method, I can pass any number of arguments here. So it's just that I have to define asterisk tup or any name. It can be any name. So why tup I am writing here? Because the this basically the function basically receive these arbitrary argument as a tuple of values. So when I'm printing this tup here, right? So in the output, it is printing this as a tuple of values. So here when I'm calling f1, I don't have any fixed number of arguments with which I can call. So in the next line, I can also call with just one argument. Then 1 comma 2 comma 3 comma 4 comma 5 comma 6, something like this also I can do. And each of the time it will basically take the random arguments to this particular method, this particular function. So whenever you are not sure that how many arguments you need to basically use inside a function, it can be a dynamic thing, right? It's something like varargs, vargs basically in Java. It's the equivalent of vargs in Java. So this is about arbitrary arguments when you are not sure how many arguments you want to. I mean, it's basically the dynamic arguments. If you want to have dynamic arguments or if you want to have dynamic parameters in a function, you basically go with arbitrary arguments. Next one is keyword arguments. Okay. Now, how keyword arguments basically work? So let's say uh, I'm writing a comma b comma c here in the function parameter. and then I am printing A comma B comma C, right? Now, when I'm calling this function, I will call with key value pair, meaning uh, if let's say I want to give value of A equal to 1, B equal to 2, C equal to 3. So what I'm doing here, so whatever are the parameter name that I have defined in the function, so key I will be keeping that parameter, and value is something what I want to, call my function from. So this way, when I will run my program, it will print 1 comma 2 comma 3. Now, what is the difference between the keyword arguments and just simply 1 comma 2 comma 3, right? So basically, here what I am doing, without a equal to 1, b equal to 2, c equal to 3, I am just calling f 1 comma 2 comma 3. But here I am doing a equal to 1, b equal to 2, c equal to 3. But when I'm running the program, it is printing same output, right? Now the benefit of using keyword argument is that you can provide these argument in any order, right? If you will provide like this also and run the program, it will still print the same output. So the order in which you want to provide the argument, it basically removes that restriction when you are using keyword arguments. So in this case, the order of argument doesn't matter. But here, if instead of 1 comma 2 comma 3, you do 2 comma 3 comma 1, then the output will change here. It will print 2 comma 3 comma 1, because here the order is, you know, it's hard linked to the parameters that I am providing in my function definition. So this is about the keyword arguments. Now, next thing is arbitrary keyword arguments. Now, how what is basically arbitrary keyword argument? So it basically combines the concept of arbitrary arguments as well as keyword arguments. So this is same as arbitrary argument, but here function receives a dictionary of arbitrary arguments. Now, what do I basically mean by a dictionary? So let's say, so in arbitrary argument, how do I define? I used to define using this, right? That is something I basically used to define the arbitrary argument, correct? Now, in case of arbitrary keyword argument, how will I basically define? So instead of single star, I will basically use double star, and it will basically denote a dictionary. So let me change from TUP to D to avoid any confusion. And when I'll be calling this method function, what I can do here is that I can pass um, any number of arguments in a dictionary format. What do I mean by that? So let's say basically I can what I do is that, let's say, name I am providing as Abhinav, and then uh, city I am providing as Bangalore. And when I'll run this program, so what is happening here? I am providing the arguments in key value pair, right? Correct? Which which is basically which I was doing in the case of keyword arguments, correct? I was doing that. And here the parameters here, the parameters that I'm passing, these are the arbitrary parameters, right? So it is basically combining the concepts of arbitrary parameters. So here it is parameters because these are parameter, but when I was calling, but when I'll call from, when I'll call this function, then it will be known as arbitrary arguments. So when it is, combining the concept of arbitrary arguments and keyword arguments, it is known as arbitrary keyword arguments, right? So in the output, you can see whatever I have provided, it is accepted as a dictionary, and it is, printing the final output in dictionary format. And I can add any number of, key value pairs: city, name, city, and then, country, something like that. So it will accept any number of keyword arguments, and it will print the output as dictionary. And let's say if I want to just accept the name, or if I just want to access the name, so it will be as usual. It's the same concept. How do I basically access the value from a particular key in dictionary? So this is about the key arbitrary keyword arguments. Next is the optional argument. So optional argument means, let's say if I am defining country as a parameter, and I am defining its value while, I'm defining the parameter itself. So India, if I am doing, and I am printing country here, right? Now in this case, if I'll do print F1, sorry, if I'm just calling F1, so what is happening? So this particular parameter becomes optional. As soon as I'll provide the parameter value also inside the function definition, so this particular parameter becomes optional. What does it mean? So it means that when I'm calling the function f1, it's an optional thing. Either you can pass the value of country while calling this function, or you can omit it. So if, let's say, if I am just omitting it, and if I'll run the program, it will print India. So this is where I am omitting. So whenever you are not passing this optional parameter, it will take whatever you have defined in the function definition. But let's say if I am passing the value as Russia, now in this case, when I'll run the program, so this will not hold true. It will only hold true whenever you don't pass any argument while calling the function. So when I'll run this program, it will print Russia. And then you can also provide, in keyword key value pair also, correct? So country equal to Russia also you can provide, it will again print the same output. So this is about the optional arguments, right? So now there are some rules also with these arguments. So what are those rules? Let's see that. So whenever we are using arbitrary parameters or keyword arbitrary parameters or keyword arguments, so these should be placed in the last or the rightmost side. What do I mean by that? Let's say I am defining a function with parameters as a, comma b, comma c, and I am printing all these three values a, comma b, comma c. Correct. Now let's say I am calling this function in couple of ways. First way is f1. Let's say I am doing 2, comma b equal to 3, comma 4, something like this. Let's see what happens um, when I run. Okay, you can see here before running itself, it is throwing an error, right? If I'll run it also, it is throwing an error that positional argument follows keyword argument. That means that whenever you are using the keyword argument, it has to be the last or in the rightmost part of the function call. So if I'll run it now, okay, why the error is coming? Because when I'll put it on the last side, see these A and B, the order is already fixed here. So whatever you will provide at first position and second position will already go in A and B respectively, right? 2 will go inside A and 4 will go inside B. Now, I can put the keyword arguments to the rightmost side. That is true. I mean, I'm doing that correctly. But B value is already been defined, which is 4. So A and B are already defined. So what I am left with, I am just left with C. So if I'll do this now, it will print the output 2 comma 4, 4 comma 3. Good. So whenever you are using keyword arguments or arbitrary, parameter, it should be placed in the rightmost part of the function call. Let's say one more example. Let's say um, I have I'm using the arbitrary argument as A and normal argument B. Correct? Now what I can do, if I will try to pass 1 comma 2 comma 3 and then like this, let's see what happens. Okay, it is telling that, sorry, 1 second. Okay, it is telling that missing one required keyword, only argument B. And if I will just reverse this order, B comma star A, in this case, if I'll run it, it will run fine. How it is running fine? Because the arbitrary argument whenever you are defining your function, it has to be keep on the rightmost part, right? Now what is happening here if you look closely? So you will see here that I have provided the arbitrary argument toward rightmost side, and we have seen that it accepts the value as tuple. But when I'm calling this function, this is the tuple that I'm passing. So you might get confused that this tuple will go in this inside variable A. But it will not happen like this, right? It will follow the order in which I have defined my parameters. So this as a tuple will go inside variable B, because the variable or the parameters of function can accept the data type, any data type, right? And then the single value what I am providing should go inside this tuple. That's why in the output, when I'm printing A comma B, this is printing the tuple with a single value, and B is printing the value as a tuple that I am passing. So whenever you are defining arbitrary parameters or keyword arbitrary parameters, keyword arguments, it has to be towards right hand side or the rightmost part in the function definition or in the function call. Cool. Now the return value, right? So whatever we are seeing here, we are seeing here that this function, whatever the examples of functions that we have seen, it's not returning any value, right? And in Python, function may or may not return value, right? Let's say if I'll define a function which returns a value, so how will I define that? Let's see a very simple example. Let's say um, I am passing the value inside this function as 2, and I am returning the square of that value, right? Now what is happening? So if you want your value to be returned from a function, you have to use a function, you have to use a keyword known as return keyword. And if you run this program, Nothing will happen because what is happening here? I am passing the value 2, it is going inside this variable a, and it is returning a into a, which is 2 into 2, which is 4. So in this particular step, value is returned, but are you doing anything with this value, returned value? You are not, you are neither printing it, you are neither using it for your further calculation. So you have to do something with the return value, right? Let's say in line number 5, I am doing b equal to f12, and then I am printing b. So in this case, it will print the value 4. So the concept here is that if a function is returning any value, you have to do something with that value, either print it or either use it for your further calculation. It's up to you, right? So just keep that thing in mind, that whenever you are returning, whenever your function is returning some value, you have to be very aware about what you have to do with that returned value, right? So a function basically can return a value. If it is returning a value, you have to use a keyword return and then whatever value you want to return. And if it is not returning any value, then that particular function will execute on a standalone, standalone manner. So this is the concept of function which returns a value, right? So uh, I'll add one more row here, right? Function returning something. So this we have already seen. Now next, very important and um I would say confusing also, global versus local variables concept. So what is global and local variable, right? Uh, First, let's see what is global variable and local variables. Let's say if I'm defining any function and okay, sorry, yeah. So I'm defining any function f1, and let's say I am defining inside this function, I am defining s equal to Python. Fine. And inside this, I'm printing s, and I'm just calling this function f1. So what is happening here? If I'll run this program, it will print Python. So nothing, new in this. But the thing is that, so this particular variable s, whatever is defined in a function, this is known as local variable. So local variable is any variable which is defined inside a function, right? And the scope of this local variable is within this function only. So you can, within this function, you can use s anywhere, right? So s can be used inside anywhere within this function. But if you want to use this s outside the function, it will not happen because the scope of this variable is local. So you can see when I'm trying to print the value of s, it will say import this name, right? Which means that s cannot be used inside the function where it is defined. So the first rule says that local variable can be used inside the function where it is defined. Okay, this is rule number 1, and we have already seen that. And second rule, I mean, okay, second rule also I'll write, which we have also seen, is that local variable cannot be used outside the function where it is defined, right? We have seen this also. Now, coming to the global variable, what are global variable? So global variable is something which is defined on global or outside all the functions. So let's say a equal to gen AI if I'm writing. So this particular variable a is known as global variable. Now, global variable can be used anywhere globally. It can be used inside this function also, and it can be used outside this function also anywhere, right? Let's see that. So if I'll do print a here and then print a outside the function, so both of these time it will be accessed and its value will be printed. So here also it will print GenAI, here also it will print GenAI. It's just that here I am trying to access it inside a function, here I am trying to access it outside the function, right? So the next rule, what does it say? It says that global variable can be used anywhere, right? Now let's go to the next rule. Now what does my next rule says? Let's say I can land in a situation where the global variable's name as well as the local variable name both are same, right? What will happen in that case? Here if I'll do print s. Now this looks confusing, right? This is global variable that I have defined GenAI, and this is inside a function also I have same variable name s with the value Python, and I am accessing these both inside a function, outside a function. If I'll run this program, it will print Python and GenAI. So the next rule says that the local variable have high precedence than global variable inside function, which means that within a function, if I have defined the local variable, so this is a local variable I have defined, right? And this is a global variable that I have defined. So inside the function, the local variable will have more precedence or it will have more priority. So inside function, if I'll try to use the local variable, I mean, if we have a local as well as global variable name same, then inside the function, local variable will be, given higher priority. That's why this particular print statement is printing Python here, right? And outside this function, the global variable will, take back the control. And when I'm doing this print s, it is printing GenAI. So what does our next rule says? It says that uh, local variable have high precedence over global variable inside a function, right? So this is the next rule that we have just seen. Now coming to the next rule. So it says that value of global variable cannot be changed inside the function. Okay, before that, let's say um, I am doing here it is Gen AI, and let me instead of s equal to Python, let me do s equal to s plus Python. ओके इसमें s plus equal to Python. ओके what I'm trying to explain, I'm just seeing how I can make you understand that concept. Say hello. Hmm. What error it is doing? Okay, create a parameter. If I'll create a parameter, okay, that doesn't make sense. Okay, okay. Yeah, so I mean, this error is a valid error, right? So what is happening here? I told you that this rule, whatever that, okay, so this is a global variable right now, and I'm trying to change the value of global variable inside a function. And the rule, the current rule is saying that value of global variable cannot be changed inside the function without global keyword. So what does it mean? Now, if I'm trying to change the value of a global variable here, right? I don't have any local variable defined inside a function, right? Uh, if I would have defined something like this, then in this line there should not be any error, because in this line it will basically change the value of the local variable, because my I have defined a local variable inside a function, right? But let's say I don't have any local variable defined in a function, so only in this whole program only global variable is into the consideration, or is into the picture, right? I cannot change the value of this global variable. If I want to change the value of global variable inside a function, then what I have to do is that I have to write a global keyword inside this and the name of the global variable. Now, when I'll do that, I'm just making a declaration that boss, whatever s you will use inside this function, this is of global scope, which is defined, which is defined somewhere outside this function, and I am giving you the permission to edit this global variable inside this function. So when I'll run this program, so first this is called, right? And it is printing GenAI plus Python, and the value of s got changed. So whenever I'm printing print s, it is again printing the same GenAI Python. It's not printing just the GenAI, because what is happening? So first time, so when I'm doing s equal to s plus Python, so Gen AI Python, it has changed the value of this global variable. Where have this changed the global variable value? At this point, right? And at this line, the value of global variable changed. So it will be reflected everywhere in the program now. So even at this line, when you are printing s, that is the global variable, it is again printing GenAI Python. So my next rule that I am discussing here says that the value of global variable cannot be changed inside a function without using the global keyword, right? Understood? And that we have already seen, right? Cool. So this is the rule that we have just seen. Okay. Now, one second. The next rule says that, okay, so next rule is the extension. I mean, we have seen both of these, right? Cannot be changed. And if you want to change it, how do we change? We can change it by using the global keyword, that we have already seen that. Now, next rule says that you can declare a variable as a global variable from inside the function by using the global keyword. So inside the, let me remove this global declaration of s equal to GenAI, right? And inside a function, I have defined global s, and then I am giving the value of s as, let's say, Python. And if I'll run this program, it is printing both. So what it is saying, what I'm doing here is that I'm using a global keyword inside a function. This gives me the power of creating a global variable from inside a method, from inside a function. So global variable, so this is global variable creation. from inside a function. So that is why when I have created this global variable from inside a function, and when I'm printing it inside a function, it is printing Python. And then from outside the function also, when I'm printing, it is again printing Python, because S is created as a global variable now. So we have seen the two usage of global keyword, right? Global keyword has two usage. What is the first usage? The first usage is that it is used to edit, or instead of edit, let me write update the value of global variable from inside the function, correct? And the second usage, what we have just now seen, is uh, it says that, or the global keyword is used to create the global variable for the first time, right? From inside the function. So this is a tricky concept, not tricky, I would say. I mean, a lot of people might not be knowing this. So global keyword can be used in two ways. First way is this one, and the second way is this one, right? So going back to our mind map, the next rule is basically uh, says that global, uh, uh, if we want to create a global variable from inside a function, we use we have to use global keyword, right? So this is the next rule that we have just seen. Cool. So this is about the global and local variable. So next thing what we will see will be the nested function. Before that, we'll have a quick quiz now. So guys can open menti.com, and you can use the key as 1545851. So we'll have a quick quiz, then we will have break, and then after break, we will start with nested functions, right? So I'll wait for you guys to join, and let me start the quiz. Okay, three players are ready. So we are around seven players, around six players should be ready, because I can see six people in the meeting. I'll wait for, you know, I'll wait for some time before all of you can join. So please join this. I have already shared the code. It is also displaying on the screen, 154585551. You have to go to the menti.com, and then you can write down or use this particular code to join this quiz. So I can see four players are ready now. Five are ready. One is missing. Can one player who has not joined yet, can you please join? Okay, let's start. We have five players. Let's start the quiz. So I'm starting the quiz. Be ready. The fastest one to answer the correct answer will be the winner. What is A if A equal to? this particular thing. So the correct answer is empty dictionary, right? Let's go to the leaderboard and see who has answered it correctly. Okay, Sarthak has answered it fastest. Let's go to the next question. Next question is, indexing is not applied on which of the following? Oh, only one. Okay, only one correct answer. Okay, who is Pingu? I am not sure who is Pingu. So indexing is applied on everything except set, right? String 0, 1, 2, 1, 2, 3, 4, and then -1, -2, negative indexing also applied there. Okay, let's go to the next slide. What is the output of this print statement? Okay, only one person has answered it correctly. The correct answer is 10. Let's go to the leaderboard. Okay, only Sarthak has answered it correctly. Now let's go to the next question. Question number 4. Here it comes. What is the output of this print statement? So the correct answer is false because it checks that whether 4 comma 5 is a superset of 1 comma 2 set, right? Which it is not. So that's why the correct answer is false. Let's go to the leaderboard and see who is leading. Pingu and player got it correct, but still Sarthak is leading. Now let's go to the 5th question. Which of them is mutable? Read it very carefully. Which of them is mutable? So the correct answer is list. Except list, everything that you can see on screen is immutable. Frozen set is a immutable equivalent of a set. String is already immutable, and tuple is a immutable equivalent of a list. Let's go to the leaderboard and see who has answered it correctly. So Deepak and Vedansh had answered it correctly. Okay, so Deepak is leading the charts. Sarthak second, Vedansh third. Okay, let's go to the last question. Okay, so here comes the last question. Let's see who wins the overall quiz. So dictionary keys must be Mutable, immutable, numbers only, or strings only? So the correct answer is immutable, and I think most of you got it correct, right? So let's go to the final leaderboard and see who wins this. So Deepak is the winner with 2,877 points. Cool. So this was about the today's quiz. Let's take a 10 minutes break, and we will start with the okay, something is okay. We will discuss nested function after the break. Yeah. See you after 10 minutes. Hey, welcome back. So we will now start with nested functions. So nested function, uh, basically when we use inner functions, so a function inside a function is known as a nested function, right? An outside function is known as, I mean, the inside function inside the outer function is known as inner function. Let's see, how do we define the nested function? So this is outer function. Let's say I'm giving, and value a is something that I'm passing it in the parameters, and then I'm defining one more inner function b, and then I'm printing b, and let's say print uh, first print of outer, and then after printing I am calling this inner function, and with some value, let's say 1 I am passing, and from outside I'm calling outer function with, let's say, value 10, right? And what can we do here? We can also print the value of a also here. Print, let's say, a I'm doing. Okay, now you can, if you can look closely, and before, let me run this program. Okay, now what is happening here in this case? So this particular function is the outer function, right? And inside this outer function, the function, inner function that I have defined, this is the inner function, right? Now, the value of a, basically, I am passing from outside everything, right? So value of a becomes 10 here, which goes inside this. It prints 10 here in this line. And then we have a inner function. Inner function itself accepts another argument or another parameter b, and I am printing the value of that b and then first line of outside function. So if you can see, so sorry, I have to omit this part. So this part is the only, this part is the inner function. So this line basically comes under outer function, the print statement. And when I'm running the program, it is first printing the value 10 here, which I have passed from this line when I'm calling the outer function. And then it is printing first print of outer function because, as I said, right, the function will only be run when it is called, right? So I am going from top to down. So top to down this is just the function definition. I haven't called it anywhere as of now. So that is why the first print of outer function got printed here. And then from the body of the outer function, I am calling inner function. So now what happens is that it will go pass the value 1 into b, and then it is printing b. So that is why 1 got printed at the last. So this is the concept of basically the inner function, right? So just remember that you can create a function inside another function, and then the innermost function that you create is known as inner function. Now, some of the rules around functions. Let's see the rules also. Mm, uh, rules. what do I mean by rules? So first is the Python functions are object. And what do we mean by this is that it basically, as we have seen, right, even the variables, every variable in Python is like an object. So it means that you can store the value of function in a variable, right? So function can be stored in a variable. Second thing, function can be passed as an argument to another function, right? And we have already seen a function can return, okay, a function can return any value, but a function can return a function also. And last thing is function can be stored in data structures. Now let's see these points one by one. So function can be stored in a variable is something which we are seeing now. Let's say um, I define one function def f1 and I am accepting parameter s, and inside this what I'm doing, I am returning uh, this s to upper. So what I'm doing is, so I'll pass the string and it will return the uppercase representation of that particular string. Now what I'm doing is that, so let's say if I'll do print and I'm calling f1 and inside this I'm passing Python. If I'll run this program, it will just return the uppercase representation for this Python, right? Now what I will do is that instead of this, let me comment out this. I create one variable and I am storing this function f1 like this, right? And when I'll do print a of Python, it will again work in this similar fashion. So what I'm doing here is that this line, I'm storing function in a variable. So the rule that we have just defined sometimes back, the first rule says that functions can be stored in a variable. Now, when you are storing this function in a variable, just think that, I mean, you know, just think that the function name f1 is changed to a now. So that's why in the next line, when you have called this, function with this particular, the variable in which the function is stored, so it again yielded the same result. So this is about the first rule that we have discussed, that that function can be stored in a variable. Now, the second rule says that functions can be passed as an argument to another function, right? Let's see this example, how we can achieve this. Let's say, okay, let me think how I can explain you this. Mm, okay. Mm, okay, let me define, couple of functions here. So define, let's say I'm writing something shout and as I'm giving here, what I'm doing is I'm returning return s dot upper. Let me do that. And then uh, s dot lower. And I'll define def greet print greeting. And यहाँ पे greet, shout, greet, whisper. Okay, this is fine, correct? Okay, so what is happening? I'm passing shout in the greet function. Let's see how it will work. This I am passing as an argument, right, to another function. So shout is a function which I have passed as an argument to this function. So this is again a function. Before that, let me run this program. So it is printing in uppercase first and then all in lowercase. So what is happening here is that, so this is a function, correct? This is a function, and these two are also a function, right? Now in this line, if you see in the line number 12, what I'm doing is that this shout and whisper is a function, correct? What I'm doing, I'm passing function as an argument to another function, right? And inside this particular greet function, what is happening? Uh, so this function I'm calling. So right now, this function, whatever func I have, whatever I have defined, can be anything, right? In line number 12, it is shout. In line number 13, it is a whisper. It can be any function. And then you are passing a value inside that, and then you are printing the value, which is basically returned. So first time when I'm passing the shout function, it is printing the Python all in uppercase. Second time on line number 13, when I'm passing whisper, it is basically printing the Python in all lowercase. So this is how the functions can be passed as an argument to another function. Any doubt? It may look a little bit confusing, but again, so you have to do some hands-on your system on your own. Then you will be able to understand it more accurately. But any doubt in this? All good? Cool. I'll take it as a yes. Okay. Moving on to the next concept, which is the concept of lambda. Okay, so lambda uh, is something which is new, all right, new in Python. So it is an anonymous function that is defined without a name. So when you define a function without a name, it is it is known as an anonymous function. It can accept any number of parameters, but can return only one value in the form of expression. And it is actually useful when we use them inside another function. Okay, before that, let's see what are lambdas and what is the syntax of the lambda. So lambda basically where you define with the keyword lambda, and then uh, parameter, parameter, and then colon sign, and then expression. So parameter and expression are segregated using a colon symbol. Now, uh, let's say um, the next thing that we have to see is how do we call a lambda function, right? So यहाँ पे let me add calling lambda function. How do we call the lambda function? First is without a name, or rather I'll use with a name first and then without a name. Okay, let's see how do we call with a name first. So let's say I'll define a lambda. I'll use the word lambda, keyword lambda, and then the first is the parameter, right? The x parameter and then the expression. I'll just simplify this, further. And I am storing this in a new variable y. And I will, I'll just do y of 2, no print statement here. Let's see whether it works. Okay, it's not working. So for that, I have to use a print statement because I'm not printing anything anywhere. So that's why nothing happens or nothing, displays in the output. And now it is printing 3. Okay, what it is doing. So this thing, first part, what I have told you, this is known as parameter, right? Or parameters. This is parameter. And the second part is the expression or the body of the function, right? So if I have to convert this into a normal function, I will, let's say define some function, and I am taking the value of this lambda expression into y. So let me define this function with the name y. First part is parameter, so I'll define that something like this. And then second part is expression. So expression may x plus 1 what I'm writing. So it is something like return x plus 1. So this is how this particular, this particular, what do you call, function is converted into a single line using lambda. And that's where the lambda are used, just to, reduce the number of lines of the code. So this is how you define lambda by naming it. Now, without naming it, uh, basically, how do you do that without naming it? So without naming, uh, यहाँ पे what you have to do is that just remove this, just remove y also, and let me directly put this inside print statement like this. And after this print statement, in this print statement, I will pass on the calling value also here. And I'll just close this. So if I'll run this program, it will again print 3. So what is happening here? I'm not naming this. I'm not passing the value of this lambda expression into some variable. I'm just defining the lambda expression here. And in the same line, I am calling, I'm basically passing the value of 2 in the parameter of this lambda expression. So this is how we can call a lambda function without name. And uh, in the last example that we have seen, here we are doing like this, right? Print y like this. Now another way what I can do here is something like a equal to lambda. I mean the same expression I can write, and I can also include the calling part here itself. When I am defining the lambda inside a variable, if calling part here, if I'll define, then I just have to simply do print a instead of the above we have seen, right? Here we are doing print y by passing the argument value of the argument, and here we are simply, printing the variable name. If I run this program, both of these expressions will work fine. So this is about, quick explanation about the lambda expressions, right? Now, the next part that we are going to see is exception handling. Let me create a new mind map and let's quickly uh, before that, let me save this. Let me create a new mind map. And the topic is exception handling. Cool. And what we are going to see in exception handling, first thing is what it is, and second thing is raise keyword. Third is assert keyword. Okay, so these are the high level topics. So what is exception handling? So exception, before that, what's exception? So that's an exceptional situation in your program which can appear in a specific situations only, exceptional situations, right? So in those exceptional situations, the program execution halts, or it basically interrupts, uh, suddenly when those exceptional situation arises. Hence, the name exception comes. So, exception is basically something which basically which is raised in an exceptional situation, and we have to handle these exception. Otherwise, our normal program execution disrupts. So let's see uh, what is exception, huh? Let's say uh, let's say value of, okay, I'm doing print 5, or let's say 6 by a, and I'm defining a as a as 2 here. If I'll run this program, it will print 3.00. But let's say if I'll make this a as 0, what happens in this case? It basically raises the zero division error. So every exception in Python is suffixed by a term error. Just remember that. Yeah. So it's a zero division error, which is an exceptional situation. And what is that exceptional situation? That exceptional situation is the value of a becoming 0, right? For any other value, the program will run fine, but there is an exceptional situation, which is when the value of a becomes 0, is something when the program execution disrupts, right? So after this, let's say I'm doing print hello, and when value of a equal to, let's say, something else, a2, so it will basically print the value 3.0 and hello. So this is the normal execution flow, right? In this exceptional situation where the value of a becomes 0, if I run it, see, the normal execution disrupt, it has thrown the exception, and my further line of code, this do not get executed, right? So this is what we say when we say that the normal execution disrupts, right? So these are the situation, or this is the situation, or this is the example of exception. Now, in order to handle this situation, uh, what we can do is that we can use try except block. So what is try except block? So this is try block. So anything which you doubt that that particular piece of code can raise exception, you put that inside try except block. So means, what does it mean? Uh, I'm writing something inside this printf statement. Okay, what does it mean is that, let's say the value of A is normal, let's say 4 value, and when I'll run this program, it is printing 1.5. What is happening here? I am doubtful that this line might raise an exception. So I have put this line inside a try block, right? And except block is something which defines that what you have to do when the exception occurs. When exceptions do not, occur, then this will be ignored. So what is happening here in this case? This got executed, this got executed, this will not be executed because no exception occurred, and this got executed. So it has printed 1.5 and hello. So this is the normal flow of execution that happened. Now let's say if a value of A becomes 0, in that case, what happens? Uh, Execution, when fifth line was executing, in this line, value of A becomes 0 happens. So it will not print anything because that's an exceptional situation. And as soon as the exception got raised, it went inside the except block. It has printed that exception occurred, but let's continue. And then the line number 9 got executed, hello. That means in order to maintain the normal flow of normal execution flow in the program, you have to use try except block, right? So that your normal flow of execution do not get interrupted and your normal flow of execution happens. So I mean, you have seen, right, in the output it haven't shown any error which it was showing previously, right? So that's how we basically use try except block. Now the next thing was the raise keyword that we want to see. What is raise keyword? So raise keyword is something similar to throw keyword in Java. What does it mean? It means that uh, you can explicitly raise the exception. Explicitly raising the exception means, so these are some situations for which Python internally has built an intelligence within its system, that whenever these situation comes, Python automatically raises the exception. But let's say I want to be the controller, or I want to raise the exception whenever I want. So how do we do that? Let's see that. Let's say I'm writing a code. If A value is equal to 5, I want to raise the exception. Before that, let me define some value A equal to 2. But if the value of A becomes 5, I want to raise an exception. So for that, I'll use a keyword raise, and then I'll use the exception, and inside whatever message I want to print, let's say um, coder is explicitly raising the exception. Fine. And print hello, I am writing something like this. Okay, so what is happening in this case? Value of A is 2. So what will happen? It will not go inside this block, and it will just print hello. When I'll run this, it is printing hello. But let's say if the value of A becomes 5, and if I'll run this program, you see this? I have raised the exception manually, or it's a custom raised exception, right? When I'm, raising the this exception when value of a becomes 5. So I raise an explicit exception using the raise keyword. And you can see whatever I have provided inside this as a parameter, as an argument, it got printed when the final exception got printed in the output. Coder is explicitly raising the exception. So this is how the raise keyword works, right? Now, uh, next one is the assert keyword. So what does assert keyword do? Let's say I have two variables, a equal to 4, b equal to 0, and assert b not equal to 0, print a by b. If I'll run this, okay, b assert b equal to 0. Okay, okay. So basically, assert, what does basically assert do is, so assert error is one of the exception which is used, which is basically do some checking, right? What is that some checking? Let's say I want to see whether b is not equal to 1. B is not equal to 0 means whenever the value of b becomes 0, I want to raise an exception, assert exception, that my check that I want to do fails, right? If b is equal to 0, if b is basically not equal to 0, then nothing happens. So in this case, let's say if the value of b is equal to 2, if I'll run it, nothing will happen, right? Let me put down some print statement also. Okay. So in this case, when I'm running, nothing is happening. It is printing hello because it is passing this step. B is not equal to 0. Yes, B is not equal to 0. So do nothing. Okay. But let's say if the value of B becomes 0, in this case, what will happen? It will basically raise the assertion here and this, and then again, right? It's like a usual assertion that Python internally raises, and then the normal execution flow gets disrupted and this print hello do not get printed, right? So this is about assertion. So assertion is something like if and else statement, and if that particular situation gets satisfied, it will disrupt and break the execution flow of the program and by raising the assertion error. So this is about the assert keyword that we can use in Python, right? Okay, so this is about the exception handling in Python. Now, next thing is classes and objects. Okay, so let me tell you, let me give you the idea about the next, couple of classes for Python. So we will be seeing the classes and object, and then we will see the concept of module, packages, library, and how to create Python workspace, pip command. And then we will see the usual libraries, right? Some of the common, most useful libraries, most used libraries like, not library, I would say module, OS module, sys module. So these modules we will see, and then after that we will, quickly we will we will start the crash course of NumPy and Pandas and Matplotlib and Seaborn. These are some of the modules and library which will be extensively used in machine learning. So I think by next weekend we will finish off Python, everything in Python, and then later on we'll start machine learning. So classes and object, I will quickly cover classes and object, and from next lecture onwards we will focus on those modules, libraries, and we will finish off the Python. Yeah. So basically classes, whenever I mean classes is basically classes and object is the concept of OOPS, right? Object oriented programming. So Python also supports OOPS concepts. And so whatever we have seen, the examples that we have seen, basically we haven't created any class, and it is the sequential, programming that we have seen. Now let's see how do we create classes and objects in Python, right? So to create any class in Python, we use the keyword class, and let's say ABC is the name of the class I am giving. So let me define variable x equal to 1 inside this. So this is the class that I have created. The class name is ABC. And let's see how do we create the object of the class. So how do we create the object of the class? Ref1 equal to ABC, and uh, mm, okay, in order to create the object of the class, I have to come out of the class body, right? Okay. So this is the object that I have created. And when I'll access x using ref1 dot x, if I'll run this program, it will print 1. So what is happening here? I have created a class ABC, right? So this is the class that I have created. It has the variables inside it. So when I'll create the object of this class at this line I'm creating, right? So this object contains the variable x, right, with the value 1. And the object is referred by a reference variable named ref1, which will point to this class object, which is of type ABC. And in order to access this value x, which is there inside the class, I will use this reference variable ref1 and then dot x is how I will access the variables of this class. So this is a very uh, simple use case of class creation in Python. So this is how you basically create a class in Python. Next concept is the concepts of constructors. So basically the constructors are something which are used for the instantiation of an object. So instantiation of an object means something uh, which is basically used to define the initial value or the value by which we want to create the object, right? And in Python, we have a method, init method is basically called as constructor, and it is always called when an object is created, right? So how do we create the uh, constructor? So this is how the object is, sorry, the constructor is created. So this is a class. Inside class, constructor is a method with the name. So this is the default name where you will start with 2 underscore, then init, and then 2 underscore afterwards. And the first parameter of this constructor is basically this is always self, basically. Self says that, okay, I mean, this is the syntax. You just have to remember the syntax that self has to be mandatorily the first parameter in any method or constructor within a class, right? So this is the constructor, and uh, let me remove this a and b for now. Let's see if it works. And let me write down print statement inside constructor, right? And what is happening? Um, यहाँ पे let me give x equal to 1, and outside class I'll create the object as ref1 equal to abc, and then I'm doing print ref1 dot x. Let's see what happens when I'll run this program. Inside constructor and ref1 dot x का value 1 it is printing. So what is happening here? So this is a class, right? And inside class this is a constructor that I have defined, and I have told that constructor are used for initial instantiation of an object or do something when the object is getting created. So what is happening? So ABC, when I'm doing this, so this is a constructor call that happens. So constructor call, it is like calling the constructor of the class. And what is the constructor of the class in this particular program? It is this init method. So in this line number 7, what happens? So this is like, because function or method, how do I call it? I'll write the name of the function or method, let's say m1, and then I'll call it like this in my program, right? So just focus on this part. It is also calling some method, and what is that method? It is the constructor. So it will basically go inside this particular method, which is nothing but a constructor. And at what particular time it is happening? It is happening during object creation, because on line number 7 I am creating the object only, right? So this is happening during object creation. So when I'll call this on line number 7, it will go inside this constructor. It will print inside constructor. So that's why inside constructor got printed. And on line number 8, when I did ref1.x, it is printing the value of x, which is 1. So this is how the uh, the constructor basically, these are basically the concept of constructor basically. Now this is the default constructor, I would say. Default, or uh, basically default constructor are some constructor where you don't have any parameter except self, because self is something which is mandatorily you have to put, right? So default constructor do not have any arguments except self. And there is something known as parameterized constructor. So parameterized constructor is something which have some parameters. So self में अगर मैं इसके, if after this I'll put I comma j, so this becomes a parameterized constructor because it has parameters, more parameters apart from just self parameter, right? And if I'll do x parameterized constructor, x equal to 0 I am giving, y equal to 0 I am giving, and inside this constructor I am giving self dot x equal to y and self dot y equal to. Okay, one more thing here. So inside this constructor or inside a class, any variable that you have defined in class, you have to access it using self keyword only. If you'll try to use directly x equal to y, let's see. Again, I think it will work. Let's see that. We'll run the program. And here, instead of inside constructor, okay, we will print in the next line the value of x and y also. And here in line number 11, as this is a parameter, as we have a parameterized constructor, right? So it is accepting two arguments here. So let's pass those two arguments, 2 comma 3 something. Let's say 2 comma 3 I'm passing. And if I'll run this program, it is printing 2 comma 3, and it is printing 0 here. So what is happening behind the scene here in this case? So I have a value x equal to 0 inside the object when I'm creating, and y equal to 0, right? Which is referred by ref1. Now inside the constructor, when it is creating or constructing the object, I have given x equal to I and y equal to j. So without the self keyword, this x and y behaves like a local variable, right? Whose scope is only limited to this constructor. So that's why when I have printed the value of x and y on this line, x became 2, y became 3. So in this line number 9, when I'm printing, it is printing 2 and 3. This is just the local variable. Now, when it executed the code till line number 11, when it is coming to line number 12, ref1.x, when I am doing, it is still 0. The value of x and y are still 0. So here, when I've changed the value of x and y as I and j respectively, it is not changing these values, right? So these are x and y here becomes local variable. Hence, on line number 12, when you are running, it is printing 0. So in order to operate on the variables that you define inside a class, you have to use the keyword self and then dot. Here also self and then dot. Now when you run the program, okay, print kill. So for printing also you'll use self.x and self.y. So when you will run the program now, see it has changed the value as 2 and 3. And as you are using the self keyword, the value of x got changed globally within that object. So x became 2 here, y became 3 here. So that's why on line number 12, uh, when you were printing ref1.x, it printed 2. In last example, we have seen that it printed 0, not 2, right? So uh, this is something that you have to take care whenever you basically deal with classes and object. So self is a mandatory you know keyword that you have to fix in order to access the variables that are defined inside a class, and self is something which will be used as the first parameter inside the constructors and inside any method that you have defined, that you will basically define inside class. So let's define some method also before we can wrap up this class and object. Let me define method m1. So m1 self, it has to be mandatorily there. So this is m1 method of class ABC. And let's say I define one more method def m2 with some parameters. So self comma, let's say s. So I will say this is m2 method of class ABC with parameter value s I will give here, and यहाँ पे okay, I am doing ref1 dot, let's say m1 in first line I am doing, and then print ref m2, and let me comment. Okay, no, I don't have to comment this out when I'll run this. Okay, m2 में I will pass parameter value as let's say 200. Okay, so what is happening here? See, this is my class. This all thing, this all part of the code is my class. This is constructor. This is method 1. This is method 2 of my class. And every method or constructor starts with first parameter as self. You can see here. And self is also used to access the variables defined within the class. So x and y are something which are defined inside the class. So I will use the keyword self. And this class, so when the class got created, so let's say the object got created, so x ka value, whatever 2 I have given, so it got created with 2, y ka value 3, and then object will also have this copy of M1 and M2, right? And this particular object is referred using the ref1 reference variable. So when I'll do ref1.m1, it will print m1 method of class ABC, and when I'll do ref1.m2 with value 200, if I'll pass here, it will print m2 method of class ABC with parameter value equal to 200. So that's how, that's where the output is. So you can ignore this part, we have already seen that. And okay, m1 method of class ABC, how it is printing none, why it is printing none. This is interesting. Cool. This is an interesting concept. So for you, just note that this is printing none. So you just have to figure out in next lecture. We'll discuss this thing, right? Why this is printing none. When I'm calling this M1 and M2, every time when I'm calling, it is printing none. So it is something that you have to, find out, and we'll discuss that in next lecture. So next lecture is more about, level 4, Python level 4 now, where we will discuss the modules, packages, library, how to create Python workspace, pip command, and then a few of the useful libraries. And then we will start NumPy, the data frames, that is pandas, and matplotlib and seaborn. So these are some of the libraries that we will quickly see, and then we will wrap up Python in our in next on next weekend, both classes, Saturday and Sunday. Cool. I think that's about it for today's class. I hope whatever I have explained you is you guys understood it, right? I think we have covered a lot of things. So you need to just, just practice and see this, lecture again and again. And you have to do some hands-on on your own. Otherwise, when I'll teach you these concepts, at that time, it will look that, you have, understood the concept. But in order to memorize that concept, so you have to basically, keep practicing these concepts on your own, and that's how they will basically, persist in your memory for longer period of time. Cool. I think that's pretty much it then. Thank you guys. Have a nice weekend ahead. We'll meet in our next lecture on next weekend. Thank you.